The Expedition 36 crew is getting set to execute the second space-based test of a system to permit control of a rover on the ground by a crew member on board an orbiting spacecraft. For today, it's flight engineer Luca Parmitano, who will be at the station's controls, commanding the activity of a rover called K-10, located at the NASA Ames Research Center in Moffett Field, California. The investigation is called Surface Telerobotics. And earlier, I spoke with the payload developer, Maria Bualat, at Ames about today's operation and the results they got from the first experiment run last month. Well, Maria, remind us what Surface Telerobotics is all about. What's your goal here?
Surface Telerobotics is an engineering test of a mission concept. So in this concept, crew in a vehicle that's either orbiting, say, the moon or Mars, or perhaps approaching a planetary body, let's say an asteroid, would control a robot on the surface. So this is an idea that's been proposed in several human exploration architectures, and what we're trying to do is test the concept, see what sorts of technologies are needed in order to realize it. One of the hardest parts of any planetary mission is safely landing on the surface. And a robot that's on the surface and controlled by crew that's orbiting or approaching can get a lot of the sort of precursor exploration work done. So, for example, a robot could be used to help prepare a landing site to make that surface landing simpler. For example, scouting out a clear area, checking whether the ground is firm, also possibly even building a landing strip to prepare for humans.
That all seems very reasonable, but it also begs a question about why is this so hard? I mean, I see kids in the park flying remotely controlled airplanes, but you got some other issues to deal with.
Yes, well, for one thing, the kids controlling RC airplanes are looking directly at the airplane, so their response and their feedback to that control is very immediate. Whereas a crew member in an approaching vehicle or an orbiting vehicle will have some communication delays. There are still some pretty vast distances between where the robot is and where the crew is. And so those delays, even if it's just a few seconds, can make controlling a robot very difficult. It can make joysticking, for example, hard to do because you need so much higher level of concentration in order to perform that task. So what we're doing is called supervisory control, where our robot is pretty smart. It can perform a variety of tasks. It can keep itself safe. And so the astronaut will actually send a sequence of tasks for the robot to do and just monitor how it's doing its job, making sure it's doing it correctly. So then if the robot has any difficulty, gets into trouble, he can step in with manual control.
Now, you've done this once before with Chris Cassidy in June. How did that one go?
That went really well. We were very happy with how that went. Chris managed to pick up how to control the robot very easily. So he completed not only the first phase of our simulated mission, but was able to continue on and get ahead of schedule and start deploying a telescope. So we did have one slight hardware hiccup towards the end of the session where our deployment device had a little hiccup, and so we think we fixed that for this next session with Luca.
You mentioned that he picked up on how to control a robot. How does the astronaut control a robot? What's the interface? What do they use?
So as I mentioned, joysticking is very difficult in this situation. So what we use is a graphical user interface, or GUI. It's running on a laptop on board the station, and Luca will see images from the robot's cameras. He'll see 3D renderings of the robot and its surrounding terrain, and then he'll use button presses basically to control the robot when he's taking over manual control. He'll be able to send fairly simple commands. So, for example, drive forward 1 meter, or rotate 15 degrees to the right, or take an image. And so those are, fairly low-level commands that he can do manually. For the most part, though, he'll be just uploading basically task plans to the robot. So the robot will run its tasks autonomously, and he'll step in just when needed.
In terms of this experiment, what are the objectives now? I think you said that you're really picking up on the same simulation that you started with the first session.
That's right. So our simulated mission is to deploy a radio telescope on the far side of the moon. So the idea is that crew either orbiting the moon or the L2 Lagrange point on the far side of the moon could control a robot on the far side that doesn't have direct line of sight to the Earth. And would deploy a radio telescope. So this radio telescope would be used to look at the cosmic dawn. So this is it's after the Big Bang when the first stars and the first galaxies were forming. So in the first session, Chris performed what was basically scouting of the site. So we've had orbital data of the site, and we have an idea of where we want to deploy the telescope. And so first we need to send the robot around to make sure that that area is actually clear for deployment. So the second part that we're going to do today that Luca will be performing is the actual deployment of the telescope. So the telescope's made up of 3 arms, and the arms are long strips of Kapton film. And for an actual radio telescope, the antennas would be embedded in the Kapton film. For our test, it's just the film. We're not actually deploying a working radio telescope. And so the robot will actually spool out these rolls of Kapton film.
You didn't just happen to have a spare radio telescope laying around.
No. Yeah, that's pretty complicated. And for our purposes, we're looking at the rover's job, not the radio telescope's job. So it's fine that there aren't actual antennas in the Kapton.
And in this case, it's again a planned sequence of movements rather than just Luca indulging himself.
Yes. So the robot's going to spool out, each of the antenna arrays, and he's going to monitor to make sure that there aren't any kinks and that the robot's, doing it properly. Also, we'll be taking images as we deploy to make sure that there are no tears in the film, and that it's all going according to plan. And then he can take over manual control if it isn't.
Assuming this goes as you have planned, what's the next step? Are there more similar sessions with this crew?
Yes, we're going to have one more test session next month with the crew of Expedition 36. So we haven't been assigned our crew member yet, so perhaps if we get Karen Nyberg, we'll have a trifecta of Expedition 36. And then after that, we'll look at our data to determine how well our systems worked, where we can improve, where are the gaps in the current technology. So what technologies do we need to develop in order to have this mission concept work? And then K-10, our little robot, is slated to do some science field work in the Mojave Desert next year.
And that be part of this experiment as well?
It's a different project. It's similar work to what you would use the robot for on the ground, but we won't be using crew members to control it.
All right. Maria, thank you very much for the update, and good luck with today's experiment.
Thank you.
Maria Bualat is the payload developer and project technical lead for the Surface Telerobotics investigation at NASA's Ames Research Center in California.